Hello everyone. This is a video on the so-called air traffic management communication navigation surveillance concept, in short ATM-CNS concept. So first of all, just recall our definition for air navigation. We have it here on the right hand side, right? And it goes somehow or follows somehow a dual definition. On the one hand, we have the single flight definition, in which we need to provide with all those services an aircraft might need to eventually fly from a given point, say an origin airport, to another point, say the destination airport, and to fly it in a safe and, if possible, efficient way. Right? That's the single vision. We're alone in airspace, and we need to safely reach our destination. That's one vision, but the other one is the so-called the multi-fly definition, in which we not only have one aircraft, but in Europe, for instance, we have 30,000 aircraft per day, roughly. Now, the situation might be different from one period to another. And the thing is that we need to also provide and facilitate information and establish procedures and ways of doing things, such that this sort of mess we have here, right? Each of these aircraft, we have here one flight, another flight, and these guys need to fly through different regions of the world, and they need to reach destination also safely. As you might imagine, things get a bit more complicated than one just single flight. So the air navigation, as we've seen in our historical lectures, has been developed in the last, say 100 years, and it has been developed in or onto three main pillars, right? Which we can mention here, these three pillars. One is the juridic, right? We need to have some legislation, and this is provided by ICAO and its different appendixes, right? And all the documents we are systematically checking. Then we have operational pillar, and this is the air traffic management. So what are the procedures, what are the rules, what are the type of things we need to do in terms of getting a slot, filling in a flight plan, what is our route, what is the procedure we need to follow, right? This is standardized precisely to ensure safety and efficiency for all flights in the day. And then, of course, we have a technical framework or pillar. This is the so-called communication, navigation, and surveillance, right? In principle, the operational framework would play a role before the execution of the flight. Months before the execution, we need to follow rules and procedures. Even right before departing, even once we are already in the air, we need to follow some procedures and some rules. But once in the air, we must also have or get in touch with the controller. Pilot controllers, they need to be communicating each other on whatever circumstance. For instance, a runway change, what is the QNH, or whether there is going to be a conflict that need to be avoided. We need to have navigation tools, navigation aids, right? This is the N here. The C is for communication, the N is for navigation. Why? Well, because we need to know where we are, position awareness, situational awareness, and what we need to do to proceed towards our next fix, our next waypoint in the route. And for that, well, you know that we have the altimeter, we have the anemometer, variometer, and all these instruments on board the aircraft, but we, in instrumental flying rules, we need to have external aids of information, and these are the VOR, the NDB, the DME, the ILS, right, providing information on radials to follow, distances towards a given fix in the airspace, etc. And then the third element of this technical pillar is the surveillance, right? Mainly the primary and secondary radars, and nowadays the ADSB. And those are guys on the ground that are monitoring and interrogating the aircraft such that the controller has information on where they are, who they are, and eventually controllers can track the evolution of a different aircraft and eventually step in if something is going to happen, right? So those are these three pillars. So let me go back to here. You have the definition, these three pillars, right? Juridic, operational, and technical. And as I was saying, this is because we need to provide with airspace structures, procedures, meteorological information we need before departing, but also once we are in the air, and then this tactical support, real-time information, conflict resolution, and all this network of infrastructures the navigation needs. Well, this leads to something. All these elements we need to provide to every single flight we're flying our skies are services, right? So we can eventually go back to our board and we have the air navigation services, ANS. Okay, and these are as follows. We have on the one hand the aeronautical information service, the meteorological service, and here we have the air traffic management service, which is divided into different services as we're gonna see later. By now, let me just elaborate a bit on these two: the aeronautical information service, right, and the meteorological service. So, what type of elements? And this is information that is typically available for the airspace users at any time. And in the aeronautical information service, we have the aeronautical information publications, amendments to these aeronautical information publications, supplements, we have also circulars, and NOTAMs, notice to airments. Okay, these are the 5 type of elements included in the aeronautical information service. We're going to see some examples now in a second. And for the meteorological service, we're going to have, of course, METARS TAF. You are familiar with this. SIGMETs, significant meteorological events. We're going to see some examples. And also, eventually, this is more real-time information or close to real-time information, but we might also want to have wind forecast or forecast of events like turbulence, clear air turbulence, wind shear, and others, right? So let me please go to check the different elements of the aeronautical information service, and then we'll go through some examples to take a look at them. So here is the air navigation services. We have not developed the air traffic management here, but we will see those guys, the ATS, ATFM, and ASM later on. The idea is that it's important that these air navigation services are provided to all airspace users flying within our airspace, right? In terms of national airspace or the sovereignty we have over that airspace. And if we go to the aeronautical information service, you will see that this provides the necessary information to ensure operations are conducted in a safe and efficient way. Here we have, again, the Annex 15 is kind of stating all the rules, right, on this. And we have, first of all, the aeronautical information publication, right, which has to do with permanent information. Right? This is not communication. This is not real-time communication. This is a stable information we can check, right? And it has to do with routes, procedures, navigation charts, aerodrome information, and so on and so forth. We'll see some examples in a second. Then we have the amendments, regular amendments to the AIP. The AIP is permanent information, but of course it's subject to modifications. And we have something very important, which is the IRAC cycle that is published every 28 days and comes with all the routes, flight level, standard instrumental departure, standard arrival, waypoints, all the elements we might need to eventually elaborate a flight plan, and this has to be embedded in the flight management system. We will see some example in a second. Supplements are temporary information, something that some issue that is going on temporary for 1 day, for 1 week, maintenance in a given runway or in a given navigate that requires extensive text or explanatory graphics for the understanding of all users. Then we have NOTAMs, notice to airmen, as information concerning some hazard that is temporary and that might compromise safety. So for instance, hazards such as air shows, parachute jumps, closed runways, military exercises, these might come in a NOTAM. And then we also have the circulars, right? This is information that does not qualify for a NOTAM, not for the inclusion in the AIP, but at some point is needed to clarify or to ensure safety. So let me for instance take a look at the Aeronautical Information Service, right? This is the web in ENAIRE, right? You have it here. If you just Google ENAIRE or AIS ENAIRE, you'll get or you will be directed to this website. Here we can click in the Aeronautical Information Publications, right? I click, and you can check this in the web. This is like this for all. I would say for all countries in the world, you can check this information. So here we can check, for instance, what is the current aeronautical information application publication, sorry, and we can click here, and this here you see the AIP, supplements, circulars, amendments, right? The past, the February 2020 AIRAC cycle, the March 2020 AIRAC cycle, which is the one that is now available. Here you have supplements, a bunch of them. Here we have circulars, a bunch of them, national, international, and the AIP, which is divided into general specifications, right? And it's always like this. Number 0, 1, 2, 3, 4, 4, and 4. I am not going to go into details, but here you have en route charts and route elements for traffic en route, and for the aerodrome, including the different aerodromes in Spain, right? This is something we are familiar with, and we are to check this information later on in future lectures related to airspace management or flight planning. Now, when it comes to, for instance, if we want to check an IRAC cycle, this is a very old IRAC cycle, right? February 2014, and you will see you will have this document available for you, and this is just the PDF format. Of course, now everything goes electronic, but you have some information, some updates to the aeronautical information publications for different airports. I don't know what's going on here. There is one private aerodrome that is not available anymore, right? You have some new vertical limits for Almeria, terminal maneuvering area, Asturias, Bilbao, For Alicante Aerodrome, Almeria Aerodrome, Asturias Aerodrome, you have few modifications that need to be published somewhere for everyone to be aware of them. Also, this is supplement. Again, this is old, but you see, for instance, that in Granada, Federico García Lorca Airport, there are some lights, type of lights in runway 917 that are not in service anymore. So if you are operating the airport, you should know that. Nothing else to say. In Bilbao Aerodrome, there are some actuations, some maintenance in the maneuvering area, right? Works for airfield improvement. Nothing else, but you should be aware of that. As for an example of a circular, this is a very old one, but I guess it's related to something we've talked about it very recently, and it has to do with the reduced vertical separation minimum, right? So this is something that was very impactful at that time, and here it explains the new concept, where it applies, right? And why the mechanisms, or why the justification, why this has been incorporated. You will see in the document that it has a lot of information, because eventually this many people might want to look at it to make sure that this is indeed was indeed true. Like, this is 20 something years ago, 22 years ago, but it was important. And then some examples of NOTAMs, right? This comes as a meta with a code, because it's kind of real-time information of some hazard. For instance, runway 36 in this airport. This is, I think, well, I was checking Nashville, an airport in the United States, in Nashville, is closed from, this is a one date and time to. It is an estimation, right? This is one example for a runway, for a taxiway, for the apron, for the whole aerodrome. Again, an obstacle, a navigation aid, communications, and so on and so forth. So you might have, this is something we are not going to study. You don't need to know this, but this is the type of information and how you get it. And it's important because now it's becoming a trend to do data science and to capture and collect a lot of data and run simulations and eventually extract some information out of them. So if you don't, you are not familiar with these codes, sometimes might be very difficult for you to actually understand some of the elements of those particular problems. So it's becoming more and more important to at least have a feeling on this type of things, where to check them, how to eventually read them, right? Okay, so if we go back to our presentation, our next service to be provided to the airspace users is the meteorological service, as we were seeing in the board. Here we have that, again, we have one met provider per country, typically. In Spain is IMET, in France is Meteo France, and they have a network of radars. They have their own prediction services, and they typically have aeronautical meteorological agency or office to provide aeronautical meteorological products. These are, as we were seeing, the METARs, SIGMETs, AirMets, and wind turbines. So we're going to see a couple of them, couple of examples. For instance, one would be a SIGMET, right? This is, again, a SIGMET, one example in which you see that this is for Boston area on one particular day. What else? This is affecting some states, Maine, New Hampshire. So it's some thunderstorm going on. What else? You have occasional severe thunderstorm or turbulence, below 8,000 feet due to some things, right? So again, this comes as a code, might have some explanation, and you might also have that in some charts, right? The pilots might have available. In principle, the information comes in a code, and you might have companies that automatically read this information and represent it somehow, right? To aid pilots, to aid controllers, to aid flight dispatchers. And then I wanted to bring your attention to this website as an example. This website is wendy.com, is making use of here on the uh, right down corner. You have like different type of models. This is the European Center of Medium Range Weather Forecasting. So this is a European model that this is the one that is implemented. You can use this for different applications. In particular, I have here airports. And here, for instance, you have winds. Winds aloft at surface, or we can move and go up if we're interested in flying, I don't know, 300 hectopascals, flight level 300. And here you have the famous jet stream that is coming in this direction. So if we are coming flying from the United States, we might wanna fly this way up through Iceland or even higher to get tail tailwinds, right? The color has to do with intensity, and here we can see current status of winds, but we have also the forecast towards, I don't know, if we are doing a flight plan, 3 hours, 6 hours, 2 days, 3 days, and we may wanna take a look at other things, such as for instance thunderstorms, right? Here you have the different radar coverage. For instance, in Spain, there is something going on here, and also in the United States. There's now apparently important thunderstorms going on near New York. You see, and this might be these are the yeah, and we have in the aerodrome we have tabs, no tabs, webcams, right? So all this information can be checked. And again, this is not an official meteorological office. This is just a website for free, and eventually they might be providing enhanced information to airspace users. But just an example of what we can provide, gathering information from here and there. This might be useful for pilots, and this is being used by pilots, by private pilots, and eventually companies have similar things, or even more sophisticated in their iPads. So I think this will be everything from this first video on ATM-CNS concept, including the aeronautical information service and the meteorological service, and then we'll go into the air traffic management and the CNS. Thanks for your time.